Okay, so this is the second part of the kind of review of the basic uses of trigonometric functions. And the good news is that if you already feel confident with how to find a missing side, how to find a missing angle uses a lot of the same ideas and steps. And so it's going to be an easy jump. So, but there's a couple things we need to learn, a couple things you need to write down and practice. So we're going to start out with a little bit of notes, and then I'll do an example for you. So to find a missing angle, we use inverse trigonometric ratios. So normally, you know how we have used in this, we've used sine, which we abbreviate SIN, cosine, which we abbreviate COS, and tangent, which we abbreviate TAN. Now we're going to use the inverse. And the way we write inverse in math is, remember when we were doing our exponential unit, I said the inverse is the opposite, and we were writing the opposite of x is 1 over x. And so to write inverse, it was x to the power of -1. It's all coming full circle. So inverse in math is written as to the power of -1. So to the power of -1. So for each of these, the way you write inverse is sine to the power of -1, and you read that as sine inverse. So out loud you would say sine inverse. And same with cosine, you would read this out loud as cosine inverse. You write it as COS to the power of -1. Same with tangent, tan to the power of -1. We read that out loud as tangent inverse. Although I'm lazy, so I might say tan inverse by mistake, because I know I do that a lot. So the question is, what actually is that? So what does that even mean? So to do this, we have to go back to, what does trigonometry even mean? So remember I told you at the start that trigonometry back in the day, it's just a ratio. Sorry, let me back up. So trigonometry is just showing you the ratio between different sides of triangles when those triangles are a specific shape determined that can be described by the angle. So back in the day, you had to go and consult one of these massive trigonometric tables. And so you'd say, okay, well, I have like this kind of an angle in this corner, and then the ratio between this opposite side and this hypotenuse side, when I divide those, I get a certain number, and I can use that to help figure out sides. This is actually almost even easier. So the way this works is, let's imagine we had this already. We had these sides already. So let's imagine we had this was 3 and this was 5, and we wanted to know this angle. So what we'd do is we'd say, okay, well, what's the ratio between the opposite and the hypotenuse? Remember, because this is the opposite, this is the hypotenuse. So we'd say, okay, well, we can describe, remember we call that sine. So we call the ratio between opposite and hypotenuse sine. So the sine of whatever this angle is equal to 3 divided by 5, that ratio. And when you do that, that comes out to 0.6. And in this case, we don't know this angle. So we have like the sine of an unknown angle, but we do know the ratio already is 0.6. So what they would do back in the day, what my mom had to do in school, for example, is go into these tables and look in the sine list. And she'd have to look in the sine list and see, okay, I'm going to try to find 0.6 or whatever I can that's closest to it. So she'd go down, okay, this whole first column is sine. So, oh, wait, found 0.6018 is 37 degrees. So she'd say, okay, well, I guess if the ratio, if I already know the ratio, then the angle that has that kind of ratio is, well, this is a little bit too big. So maybe it would be just under 37 degrees, but probably round to about 37 degrees. And she'd say that angle is 37 degrees. That's all we're doing. Inverse means reverse, means opposite, means backwards. We're just going backwards. So last time we were using the angle and the known ratio to find a missing side. This time we're using known sides and the known ratio to find a missing angle. So I'm going to write that down. So we use known sides and the and calculate the ratio between them. So we use the known sides and we calculate the ratio between them, just like we did with this one right here. We said we knew this was 3 and we knew this was 5, and we calculated their ratio. And we calculate the ratio between them and use trigonometric ratio to find the angle. So instead of using the angle and one side to find another side, we're using two sides to find an angle. So that's kind of a simpler way. Use two sides and trig to find angle. So that's kind of our simple definition here, and it's going to make more sense once we actually do a couple examples. So if you're kind of lost right now, you can hang on, that's okay. So how to write each inverse trigonometric ratio. So we write it a little bit differently. So normally you've seen the sine of an angle is the ratio between that opposite and that hypotenuse. The inverse, we're going to say the inverse sine, or the sine inverse of that ratio equals the angle we're looking for. So this is how we're going to write it down. So the inverse sine, or the sine inverse of that ratio is equal to the angle. So this just means that sine inverse is the thing we're going to do, the process we're going to do to use the ratio to figure out the angle. What my mom had to do back in the day was just go backwards on the table. So instead of using degrees to find the ratio, she used the ratio to find the degrees. She just went backwards. Luckily though, we don't have to carry around these really long tables because we have all of these ratios for every single trig function, and way more exact than this. We have them down to like the decimal. We have them all already stored in our calculator, so we don't need to use these. So the way we write it down to represent it is very similar to the way we write it in our calculator. So that's why I just want you to know how this is written. So for example, these would be regular trig ratios, and these would be inverse. I'm going to write them in 2 rows here. So if normally we write the cosine of an angle equals the adjacent side over the hypotenuse, the inverse is just the backwards. So the cosine inverse, or the inverse cosine of that ratio between adjacent and hypotenuse, will give you that angle. Same thing for tangent. The tangent of an angle normally gives you the opposite over the adjacent ratio. And remember, when I'm writing this little symbol here, this is, in case you've forgotten, this is the Greek letter theta, and we just use it to represent, it's an unknown angle. In math, it's really commonly used, just like how, it's not the only thing that you can use, but it's just like how in algebra, x is often the variable that's used, even though it's not the only variable that can be used. So just in case you'd forgotten where that came from. So, and for tan inverse or tangent inverse, you just write it in the same kind of way. So the tangent inverse of that ratio between opposite and adjacent will give you the angle. So this is how we write this in math language. So these are how we write the inverse ratios in math language. Now, I'm going to show you how to enter it into your calculator, and everybody has a different calculator. So yours might be slightly different. I'm going to show you on mine on the computer, and then I'm going to give you a couple things that might look different on yours, and just a couple examples of what it might look like on your calculator. So let's imagine a question here. So let's imagine that one we had before. If we had this triangle where the opposite side was 3 and the hypotenuse side was 5, and we were trying to find the angle. So that same one that I showed you, my mom would have done with the table where she looked it up, but we're going to just do it because our calculator has them all stored exactly to a lot more decimal places. So let's imagine, whoops, we had, sorry, this will become relevant later, this triangle here, and we had 3 and 5, and we wanted to know this angle right there. And just like we always do with trig, first thing we do is we label all the sides with relation to the angle we care about. So this is our angle, so this side right next to it, adjacent to it, adjacent side, across from that 90-degree angle is our hypotenuse, and opposite our angle is our opposite side. And just like with regular trig, we say, okay, well, what are the sides I have? Normally we say, what's the side I have and what's the side I'm looking for? But in this case, we have two sides. So what are the two sides we have? We have the opposite and we have the hypotenuse. So we have the opposite, we have the hypotenuse. And so then we need to think, okay, SOHCAHTOA. Remember, if you're getting lost, just write down SOHCAHTOA. And we think, okay, which one has opposite and hypotenuse? Okay, so that's sine. So the sine of an angle equals the opposite over the hypotenuse ratio. But we're now looking for this angle. So we're going to do the backwards or the inverse. So I'm going to write it down the way we would write it up here. So remember I wrote sine inverse of that ratio between opposite and hypotenuse equals the angle. So that's what I'm going to write here. Sine inverse of that ratio between opposite and hypotenuse equals our angle. And then I'm going to fill in what I know. So I know from this triangle here that my opposite side is 3 and my hypotenuse side is 5. So I'm going to say, okay, the sine inverse of the ratio 3/5 will give us our angle. Now we're going to enter that into our calculator. You can, if you want, do this division first. In this case, it's nice because it comes out to 0.6. It's even. I didn't round that at all. It's exactly 0.6. Sometimes it might not be nice and even. It might be a really long decimal. So I'm going to show you how to enter in your calculator all in one step without doing the division first. So, okay. So the calculator, let's switch to that really quickly. Okay, so we have our calculator here, and you can see that this guy has sine, cosine, and tangent, right? But if we look above each of those buttons, you'll see a little sine inverse, cosine inverse, tangent inverse. If you're on your calculator, you should see the same thing. Now it's important to note that they are in a specific color. On my computer one and on my physical calculator, because it's the same company, they are yellow, and there's also a red letter above them. That's kind of important because this works just like a keyboard. So just like on a regular keyboard, you know, when you have like the 1 and you press shift and there's an exclamation mark above it and it gives you the exclamation mark if you press shift 1. Same thing with a calculator. but sometimes they have two options and they have different buttons to help you choose whichever option you want. So in this case, I want the yellow option. So my buttons here say shift and alpha. It's really common to say shift. Some of them say second, as in second function. The one on the iPhone calculator says second, I believe. Let me find it really quickly. Yep. So don't judge my cracked screen. It's just the screen protector. The screen itself is fine. Here, let me turn off the light here. Okay, so here on the iPhone, up in the corner, weirdly located, you have a button that says second. And when you press it, all of your keys change. And now where they used to have sign functions, now they have inverse sign functions. So same idea there. In general, I don't use iPhone calculator for trig because it tends to have a really hard time entering things in properly, and you can't see all the numbers at the same time. So even though I do use my iPhone calculator for some things, specifically for trigonometry, I don't. So I'm going to show you how to do this. So if you press shift, you'll see that you have like a little button pop up just to remind you. It's like the button that pops up that says you're in caps lock. And also just reminder, this up here shows a key log. So at the top, see where it says the shift button? It's going to show you every key that I press in order, just so you get an idea. So now that I've pressed shift, if I press sign, it gives me the sign inverse. And you see it's started a bracket here. So now I can actually enter in that whole ratio. And then as long as I put a closed bracket after it, it'll do the division inside first and then give me the answer. So I put in 3 divided by 5, because that's my ratio, 3 over 5. And close my bracket, just hit enter. And it gives me 36.869897 degrees. And that makes sense because remember when we used that table, I said it was about 37, but maybe a little bit less. Well, now we know the exact amount less. It was 36.86. So if we rounded that to one decimal place, it'd be 36.9 degrees. So when we entered this in our calculator, we got that theta equals 36.9 degrees. So in your calculator, just so you have a little bit of like notes here, is press the, and it might say shift, it might say second, your second button. If you don't have either of those buttons, then send me a picture of your calculator and I can help you figure it out. Or you can just find the exact name of your calculator with the model name at the top and just Google that and then inverse trig functions and it'll show you how to enter it. But if you're having trouble figuring it out, just let me know. So press the shift or the second button, then the correct trig button to get the inverse trig function. Okay, so that's how we're going to enter it into our calculator. And now I'm just going to show you an example of how it's used, why it's used, and go over that. So an example of how we use it. This is from, this is the only before picture I could find, but last summer I was helping my dad, my brothers and I were helping my dad build this boathouse. And you'll see this nicely, we put on all the siding together. My brothers put on a lot of it. I helped with some of the siding, but I helped my dad do these shingles, which we did not realize how long this would take, every single shingle. Anyway, it took a long time. And you'll see here that if you get close to the edge, the shingles are on an angle right here. So just so you get an idea, this is the only before picture I could find on my phone. I was taking a picture of the fire and the boathouse happened to be in it. So anyway, before it looked like this and we had to cover all of that with the shingles. But these shingles here are all on an angle. So we had to cut them all on an angle. Luckily, my dad has one of these like miter saws, which you can, so see this little like black knob here. If you loosen this, you can twist this back and forth so that it cuts on an angle. So you can see right now, if we laid a piece of wood along it like this, like that, the saw blade would come down right now in this like Google Images one. It would cut this on an angle. So excellent. And second piece of good news, you can see here they actually have angle markings. So it actually shows you the number, and you can get them down to very, very specific like decimals. But the problem is that my dad is very precise. Well, that's not a problem. He's a surgeon. You want him to be precise. But he wanted the exactly correct angle. And that's also for a good reason, because if it's not the exactly correct angle and there's a little bit of a gap, A, it looks bad, but B, the rain can get behind it and then rot the wood from the inside out. So you don't want that at all. So we had to get this correct angle. So my dad said, Sam, I'm going to get lunch, figure out the angle. So what I did was use trigonometry and inverse trig ratios. So you can see that our roof section here, I think this is called the gable, is a triangle. This side is equal, this side is equal, this side is different. So that means it's an isosceles triangle. So not a right triangle, but like we did in the word problems, I could use that right triangle and cut, or use that isosceles triangle, cut it into two right triangles, and use that to figure out the angle that we're going to cut those shingles on. So what I did was I got a little scrap piece of wood and I drew this shape on it. So I drew, okay, I've got a triangle here, and I just quickly measured. This was, I think, 24 feet across. And I think from the bottom here, where we're going to put up to the top, was 8 feet. Oops, 8 feet. So I measured all the way across was 24, and this peak here was 8 feet tall. And then because this was an isosceles triangle, because, I mean, hopefully we built it right and they're exactly equal. If we didn't, that's a whole nother issue, but we did all right. I mean, it turned out. So what I did was I said, okay, well, we need to cut every single shingle that we put in on this angle here. So this angle in the corner is going to, oh, okay, I regret everything. This angle in the corner is going to be very, very important. So all I need to do is figure out, okay, what's that angle? So I said, well, if the whole thing across is 24 feet, and this is an isosceles triangle, then these little sides here are each going to be 12. So from here to here is 12 feet, and from the middle to the other edge is 12 feet. So now I have a right triangle. If you want to redraw it, you can. You can say, okay, I've got this right triangle here. So sometimes it helps just to clear your drawing up a little and write down just what you need. So, okay, I've got this right triangle here. And now I thought, okay, which trig function am I going to need? So remember, first thing you do always is you label, okay, well, this is my angle, so that's the opposite side. This is the adjacent side. That would be the hypotenuse. In this one, I didn't measure the hypotenuse, so I don't really care about it. But I did measure the adjacent and the opposite. So I think, okay, SOHCAHTOA, TOA, what uses opposite and adjacent? OA, TOA, okay. So I'm going to use tangent. And normally, tangent of a specific angle, when we enter that in our calculator, it tells us the ratio between the opposite and the adjacent side. But in this case, I have the ratio between the opposite and the adjacent side, and I'm trying to find that angle. So I'm going to use my inverse trigonometric function, which I'm going to write like this. So my inverse tangent of the ratio between the opposite and the adjacent sides is equal to my angle. Okay, so now that I have this, all I need to do is put in the numbers that I do know. So I know my opposite side, I know my adjacent side. So I write the tangent inverse of the ratio 8 over 12 equals theta, or my angle. So again, I grabbed my calculator, which I probably had my real calculator on me, but if I didn't, I could have used the iPhone calculator, even though it's not ideal. And I entered in, let me just clear this out. So I used that shift button again to get my tangent inverse function instead of my tangent function. And then I entered 8 over 12. Oops. And I got 33.6900, blah, 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 blah. So I said to Dad when he came back down from lunch, okay, our angle in this corner is 33.69 degrees. So he had me on the saw adjust it to 33.7 and then just like a tiny hair off of 33.7 degrees. And so I got that exact angle. So there are lots of cases in real life where the specific angle might be important. And in this case, this was just one that I happened to use in my real life last summer. So it was our example question. For one more example, I'd like you to try, imagine we have this right triangle right here. And I wanted to know that angle. And I had the following measurements for the sides. I had this was 4, this was 5, and oh wait, no, I'm just kidding. I'm going to give you different measurements. Hang on 1 second. Okay, sorry. So now I've given you measurements for this triangle. So let's say that this bottom part here is 3, this side is 4.5, and the hypotenuse here is 5.4. So the question is, okay, I want to find this angle. So as always, our first question is, which trig ratio, which trigonometric ratio are we going to use here? So kind of a trick question, because I gave you all 3 sides. So for this one, we have the opposite side, we have the adjacent side, and we have the hypotenuse side. So if you have all 3, you could choose whatever you want. So you could say, okay, I'm going to use sine inverse of opposite over hypotenuse to get that angle. You could say, I'm going to use cosine inverse. Here, I'm going to give a little more space here so I can write. I'm going to use cosine inverse of adjacent over hypotenuse to get that angle. Or you could use the tangent inverse of the opposite over the adjacent to get that angle. And whatever you chose, you would just make sure to fill in the correct measurements for the correct side. So if you chose sine inverse, you'd fill in, okay, well, my opposite side was 3 and my hypotenuse side was 5.4. So it'd be 3 over 5.4, and that would give us the angle. Or you could say, okay, I'm going to use cosine inverse of our adjacent side was 4.5, our hypotenuse is 5.4, so 4.5 over 5.4. Or if you wanted to use tangent inverse, you could say, okay, I'm going to use the tangent inverse of, and then you plug in the opposite side, 3 over the adjacent side, 4.5. And you could choose any one of these. So I'd like you to choose one and get your answer. And just in case you don't believe me, I can do all of these in my calculator right here. So if you had chosen to do the sine inverse of 3 over 5.4, you would have gotten 33.75-ish degrees. So 33.7 degrees. And then if you had chosen to do instead the cosine inverse, here, I'm going to write that down. So 33.7 degrees. 1 second. So that was 33.7 degrees. And then if you'd chosen to do the cosine inverse of 4.5 over 5.4, so cosine inverse of 4.5 over 5.4, 33.55. Hang on one second. I know you're having a moment here. Oh, whoops, I didn't show you that. Hang on, sorry, screens. So I entered this as a 4.5 divided by 4.4, and I got 33.56 when I round it. So rounded to one decimal, that comes out to 33.6 degrees. So if I go back, okay, that was 33.6 degrees. And if I had done tangent inverse of 3 over 4.5, let me show you the calculator this time. So if I had entered that, again, using my shift button to select tangent inverse of 3 over 4.5, I would get 33.69, which rounds to 33.7. So now I know some of you are sitting there going, but I got 33.6. Don't worry about it. That's because when I was putting together this triangle, I calculated out all of these sides exactly so they'd be correct. And this one I had to round slightly because it was a really long decimal. So that's why it didn't work out exactly the same, because I personally rounded that. But for our purposes, I would not mark you down if you wrote 33.7, 33.6, 33.7. And if I had asked you to round to the nearest degree, they all would have rounded to 34 degrees. So this little symbol, in case you're not familiar with it, means equals approximately. When you put that little tilde symbol over the equals, it means equals approximately 34 degrees. So if you got a situation in any kind of trigonometric ratio problem where you had all of the sides, you can pick any of the sides. Or same thing as if you were trying to go the other way and I'd given you both angles, you could pick either angle. So now it's time for practice. Try some on your own and go for it.